Hello and welcome to the Daily Space for today, August 2nd, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. Our summer of not having a whole lot of science releases continues. And today we have just 2 releases, and so it's going to be a short Friday. And hopefully you can all escape to go, well, help us do science. For those of you who don't know, Bennu Mappers continues. We are desperate to finish off this project, and we're hoping that you'll click on over and help us out. To help motivate you, well, we're doing a whole bunch of different things. First off, we have created a place where you can go and check out exactly how many images you have completed so far. The URL is cosmoquest.org/x/leaderboard.php. Except I just totally typoed that into the chat. I forgot the D in leaderboard, so the URL I typed won't work. Hopefully someone can type in the correct URL. So first of all, you can go see, well, exactly how much you've done, and every little bit helps. Now, one of the reasons that we're giving you the ability to see how many you've completed is we found out that those of you who are hero mappers, the folks who've done 50 or more, 100 or more images, there's a chance that the mission team is going to let you help us name the features that are on Bennu. So if you want a chance to help name the features on Bennu, well, it's time to get mapping. And as special thanks, we're also going to be looking to send out stickers, pins, t-shirts. We're still figuring out what we have, what's possible. But map all the things. All the things. Hate map Bennu with us. There are so many rocks. There are so many boulders. But together, we can find the safe places for this little spacecraft to touch down, grab a soil sample, and bounce back off and get that science done. Get that science done. Okay, so to go to our first science story of the day, we have a tale of a new kind of pulsating variable star. Now, there's lots of reasons that stars pulsate, but those that pulsate by having their atmosphere essentially breathe in and out. Their pulsations are driven by the physics of their atmosphere, and there is, in general, a band through a diagram of brightness versus temperature for these stars, and along a specific band through that plot, there's this area where the stars become just slightly unstable, where as they collapse down, some of their energy ends up going into, well, ionizing the outer atmosphere. And as they expand back out, that energy gets released, giving the stars an extra push. And this acts very much like someone always pushing a swing when the person gets to the peak of their swing, giving them more energy at just the right moment to keep them swinging no matter what. Well, we thought we'd found all the pulsating variable stars there were to find, and we were wrong. In new research coming to us from the University of California, Santa Barbara, a really weird kind of star has been found to pulsate. These stars are 20 to 50% the mass of the sun. They are 1/10 the diameter of the sun, and they're 9 times hotter. These stars are like 90,000 degrees Fahrenheit. They're hot. And I know that I, for one, first read all of those numbers put together, and I'm like, that makes no sense. These are O-type stars that are subdwarfs. And my first reaction was, how the expletive does something like that even happen? Well, it turns out it takes a little bit of stellar cannibalism. These are stars that started out kind of like our sun. They probably started out about the mass of our sun, but they're more evolved. they have finished burning up all the hydrogen down in the cores of these stars. And after they burned through all that hydrogen, they did what, well, our sun is going to do someday, and they poofed out into red giant stars. Now, normally, and this is what our sun is going to do, these stars poof out, and as they do, they eventually reach the point where helium burning is triggered in their core. Now, these stars, and this is just an artist illustration of these stars, instead of igniting helium in the core, as they expanded out, a nearby star, these are all in binary systems, a nearby star was like, ooh, tasty, and started pulling gravitationally the outer atmosphere of that star off the star and eating it. And what was left behind? That hot core that hadn't quite had a chance to, well, start burning helium, it's left behind going, hi, I'm hot. I'm really hot. I'm 90,000 degrees Fahrenheit. And it's left with a bit of atmosphere. But it doesn't have the ability to do the normal evolutionary things. And so it sits there, and it just happens to be the right combination of temperature and size and luminosity that it sets to pulsating every 5 minutes. So, yeah, if our sun was in a binary, it had the potential to have its atmosphere ripped off, leaving behind a pulsating variable star, a hot, tiny pulsating variable star. So one of the really cool things about stars like this is how we're finding them. They're really rare. It takes this specific combination of two stars that are just close enough that when the one bloats up, its atmosphere traipses into the gravitational pull of the other one and gets sucked off. So you have to have just the right distance between these two original stars. And they have to be just the right combination of masses and everything else. And we're not going to find them without looking at thousands of other stars. And thanks to our modern surveys, we have looked at those thousands of other stars. And these rare stars are starting to turn up in the mix. So this is cool. And I love reading these papers that force me to go, how does that happen? And finding an answer that, well, in this case is just a really cool story. This star got stripped naked of its atmosphere and left behind to pulsate. Now, in another article that forced me to go, how did that happen? I had a series of press releases this morning that came from the University of Maryland, came from the Hubble Space Telescope, and all pointed at not a super hot star, but a super hot planet. This planet, this is an artist illustration, is WASP 121b. It's not another test discovery. This is a different discovery. And this particular star, this particular planet rather, was previously found by the WASP survey and was now followed up by the Hubble Space Telescope. And what they found in their follow-up observations is this extraordinarily hot Jupiter with a temperature of 4,600 degrees Fahrenheit at its surface is in many ways kind of like a star. Its outer layers are as hot as a star, but it's just a planet. It's just planetary mass. It's not driving nuclear reactions in its core. Instead, it's getting superheated from the outside because it's really too close to its hot parent star. Now, this being super hot, this being super close, led to me going, how does that happen? When I read the press release's title that said this planet is football shaped. Football shaped is not a shape one normally associates with planets. But what's happening is it's getting torn by tidal forces. And on the nearest side to the star, the planet is getting bulged out by the excess gravity. And on the other side of the planet, the lower amount of gravity is causing the planet to bulge out, just like the tides here on Earth, where we have 2 high tides every day. One when the moon is almost straight overhead, and the other when the moon is almost straight below our feet. The same tidal forces that raise the ocean's tides, and actually mountains and soil and everything else, has tides as well. We're just less aware of them. Those same forces, those same kinds of tides are raised on this world, making it football shaped. And while the world is getting distorted by the gravity of its star, it is also getting tortured. It's a world that is rich in heavy atoms, rich in what we call metals in astronomy. But the solar wind of that star, the pressure from that wind is actually blasting those heavy elements out of the atmosphere of this planet, causing them to stream away. Over time, this planet is getting smaller and smaller as it's literally getting blasted by its star. Now, this is another one of those cases where this discovery is primed and ready for follow-up observations by the will it or won't it launch James Webb Space Telescope. There's a lot of science right now that is being developed because we thought that telescope would have launched last August, a year ago. It didn't launch. But all the science that was waiting for that telescope is moving forward anyways. And so when and if James Webb Space Telescope finally launches, there's going to be a whole lot of worlds just waiting to have their atmospheres discovered, to be measured in detail. And this is one of those worlds. And that's really all the new science I've got for today. As I said, we often have slow science in the summer. At some point, there will be a whole rash of papers as all the academics that plan to spend their whole summer writing papers are like, oh, expletive, the semester is about to start. And they start submitting everything for publication. And then there'll be another rash of papers as all those publications will get published. So here's to hoping that things turn around soon and we start seeing a lot more scientific developments. But I'm now going to answer your questions, so please go ahead and type them in and at CosmoQuestX in the chat live here on twitch.tv. If you miss an episode live, don't worry. Everything gets archived over on YouTube. And when I write them, we send out my summary notes to all of our patrons over on patreon.com/CosmoQuestX. Now, those are going to be late and after the fact today because I had a really unexpected... Sorry, barking dog. I had an unexpectedly busy day today where that barking dog you just experienced, he had to go to the groomers and chaos ensued. So your notes are going to be a little bit later than normal today, but they will be coming. So there's reason for you to follow us on patreon.com/CosmoQuestX, and that's to get all those show notes. Okay. And as always, this is a production of the Planetary Science Institute. We're a 501c3 nonprofit dedicated to exploration of our solar system and beyond. This means that your contributions are tax deductible where the law allows. Okay, I'm going to scroll back and I'm going to see what questions you had to ask. Yes, I have Stella is the little one. Stella, come here. Come look. Stella's like, thank you, Keeper of Maps, for the bits. So for those asking about the names, that's Stella. It's really messy in here. The half-white face dog is Eddie. Eddie, look at me. Come here. Look at the camera. You gonna hop up instead? This is Eddie, who's not going to be on camera. And the fluffier one with the tail that you're seeing is Malachi. Apparently, they only want you to see their butts today. So there's Eddie and Malachi. So, fluffs. Thank you, Veronica, for the bits. Thank you. Okay, scrolling. So much weird weather in Europe that I'm seeing you guys talk about. So much weird weather. Map all the things, Binary Ablaze says. Yes, map all the things. I do think we need to have a Boulder McRockface. I do think that needs to be the name of something. And yeah, we definitely have Pebble 10010157544128. Probably no A. I don't think we're going to do the A's and B's on Pebbles, but yeah, there's that many. Okay, scrolling. Looking for questions. So OpenCage5 says, I thought about the other end today, colliding O-type stars. So O-type stars come in a variety of different sizes, from hot and tiny to huge and dangerous. And if two O-type huge and dangerous stars collided, that would definitely lead to one hell of a set of gravitational waves being released, as well as a supernova. Luckily, those O-type stars generally end up going supernova and turning into things like neutron star pairs, and we see the neutron star pairs merge late in their life, and we're actually detecting things like that with LIGO, and that is the source of most gold. Random, important things to know. Maybe not important. Random things to know. Okay, scrolling. Crispy Jupiter. Smoking Jupiter. All of these things are true of that hot Jupiter we discussed. Yes, American football shaped. Thank you for the correction, Falco. When I say football shaped, I'm showing my bias towards American football as a shape. Rugby ball shaped. That is clear for everyone who knows what a rugby ball looks like. Who needs space action battles? More drama with stars and planets. This is true. And celestial objects are so often shaped by gravity. It's the interplay of gravity and rotation that really defines the shape of most objects. I have not seen that Business Insider piece, Larry Weird. I am opening it to see if it's a new story, an old story. I will need to look at that. That looks like something from Monday. Thank you for pointing that out. So Stormer Joe, when news from missions goes quiet, it means that things are either going okay or going terribly wrong, and it's impossible to know which. That is this sad but true. It's only when things go slightly sideways that they're public about it, until the last second. Scrolling. So Paranor asks, have you seen the new simulations that show the Milky Way is a wave? I think that's the same article that Larry sent. I hadn't seen that before. I'll have to take a look at it. So Veronica Cure, yeah, there's been a lot of heat, and now there's a lot of torrential rain in Europe. They're having weird weather over there. Thank you, Fenring, for subscribing for 14 months. That's amazing. Thank you so very much. Thank you, Planetary Pan, for subbing, and thank you, Kevlar, for the bits. Thank you so much, Planetary Pan, for the 5 months of sub. You guys are all awesome. And I think that's all I've got today. So I am frantically working on coding up a new version of the site that will hopefully be prettier. If you, as I encourage you to do, are working on mapping Bennu over the weekend, and for those of you in Canada, I am told it's a holiday weekend. I may just be sharing screen captures of the new site as it's being developed, and I'm hoping that by Monday, if not sooner, I'll be able to release the initial code base open source. I just want to triple check that I have something that isn't too embarrassing to post, but we're close. We're so close. So that's where we're at. And thank you guys for being here. As always, this is a production of the Planetary Science Institute. And we come to you most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific, that's 6 p.m. London time. We are also here on Sundays when Annie brings you the Sunday Science Hour. So I hope I'll see you around here on Twitch and over on our Discord. We are supported by you. We are so grateful for anything that you have the ability to give. And we're going to do everything we can to make you proud and turn all your contributions into science and science communications. So thank you for your bits, your subs, your patronage over at patreon.com/CosmoQuestX. And I think that's all I've got to say. I am going to raid Oh Bother. And then I'm going to go make lunch before I get back to coding. So thank you for everything you guys do. Thank you for doing science. Thank you for being there as support. Thank you for the memes you drop in on our memes channel. You guys are what keeps us going. And I don't think we thank you enough. So thank you. And wherever you are in the world, have a fabulous morning, evening, afternoon. And remember to go outside and look up, and then go back inside and help us map Bennu. I'll see you on the other side. Bye-bye.